So I want you to leave that on your desk today. You're looking for that green section. Can I use yours real quick to show everyone? So you're opening it up to this page where all your postulates and theorems are, that little sea green section, and you want to be at chapter 1 and chapter 2. Okay? So make sure you have that on your desk where you can see that along with your notes. The hardest part to geometry proofs is knowing your theorems, your postulates, and your definitions. If you don't know them, that's where you're going to struggle. So I'm just telling you, my best advice for you to be successful is that you spend a little bit of time studying the name and what the postulate says. Studying the name of the theorem, what does the theorem say? So that when you get to the proof, you're not sitting there trying to figure out what to write as your reason. Okay? And if you flip through some of those pages, you're going to see that our number of theorems and postulates is going to quickly grow. Each chapter starts to have a lot more theorems and postulates and less definitions. I'm not going to give you a theorem and postulate test, but it's going to be obvious whether or not you know them based on whether or not you can do the proofs. So you're going to have to make yourself study those a little bit, okay? We will practice, though, together, and most of the theorems or postulates that you'll have to use, we will have reviewed in class in our notes, and so that'll be helpful when you get to the homework. There may be a few that you have to look and kind of pull from as well. I've already made you set your proofs up as 2-column proofs so that that would be easier today. You're familiar with the statements and reasons and numbering them. And we have already learned a couple of theorems in here, even though this is the first time they actually define the word theorem. We've learned the Pythagorean theorem, and we've learned the vertical angle theorem. What did the vertical angle theorem say? Nope. Vertical angles are congruent. Okay, angle plus angle equaling whole angle y is your angle addition postulate. Vertical angle theorem says that vertical angles are congruent. Okay, so when we write these proofs, you are going to be given some sort of information today, just like yesterday. You were given some information, or last class period, and you're going to have to decide how to get from the given to what they want you to prove. And again, the hard part is you have to give every single step, and it has to be detailed. And so that's where things can get difficult. So you're going to start thinking, what definitions, what postulates, what properties, or what theorems do I know that will take me from my given to my final conclusion? Okay. The more we practice together, the better you're going to get at this, but it's going to be a little bit tough at first. We're going to start off pretty easy and then work our way through. And I'm going to tell you, when it says write a justification for each step, I want you to write a proof every single time. 2 columns, statements, and reasons, just like last time. So write a justification for each step. That means we're going to start with a 2-column proof. In your notes, I may have given you sometimes the little statements and reasons box. This time I didn't. What do you notice that they already have on your notes that I don't have up here? What is it? The statements. Okay, so here's the rule for the homework. I didn't say this last time, so I won't count off on the homework you just turned in. But if they give you the statements, you have to write down all of the statements. You are not just going to list 1, 2, 3, 4, 5, here's the reasons. I want you to have it set up as a 2-column proof. Here are my statements they've given me. Here are my reasons for those, okay? And the reason I'm going to be picky about you rewriting it down is because I'm trying to get you to make sure you're understanding how did they get from this statement to this statement. You're not just filling in this little blank, okay? So I'm not going to list those here. We will in a minute. Statements and reasons. Number 1. Look at what they tell you up here at the top, not what's listed down below. Given that angle A and angle B are supplementary and that the measure of angle A is 45 degrees. So today, they're going to tell you exactly what you're given up at the top of your problem. And that's what you're going to be listing in your proof. Last class period, I told you it was okay to list all the given at once, and it is always okay to do that. However, I think as these proofs get harder, you're going to find it's more helpful to write down the given when you're ready to use it and wait until you're ready to use the rest of it later. It'll make more sense. So that's what I'm going to practice with you as we go through the ones that are not just fill in the blank. Since this one is already filled in for us, we'll just do exactly what they did. So what's the very first statement you have on your paper? Angle A and angle B are supplementary. Okay, so on your paper, make that a T-table. And let's write down our reason. What is our first reason for that information? Was given to us. Okay, the next thing I'm going to warn you about is when they've already written the proof or written all the statements, sometimes that's actually harder for you. You're going to think it's easier, but sometimes it's harder because it's their way of thinking. And you've got to try to figure out their way of thinking. And the other thing that I catch a lot of students having trouble with is they'll think, oh, the given's written down. But did they write down all of the given? No, what part did they not write down? The measure of angle A equals 45 degrees. So somewhere else in your proof, say it again. Okay, but it's not in statement number 1, right? It is in statement number 1? Oh, it is. Okay, I'm sorry. I didn't know it was. So this is right underneath it in statement number 1. Later in some of the examples, it's not going to be right underneath it in statement number 1. So watch to make sure they've listed all of the given. If not, it could be somewhere later in the proof. And so I'll have students who'll say, Ms. Lash, I have no idea how they did step number 5. I don't know where number 5 came from because it was given way back up at the very beginning of the problem. They just didn't write it down till later, till they were ready to use it. Okay? All right, so here's all our given. Now, I want you to try to look at, not look at what they wrote, but think. Because the hardest part of a proof is trying to get from what's given to what your final goal is. And these are not all going to be fill in the blank. You're going to have to write an entire proof by yourself. Okay, so what your goal is when you get to these proofs is you're going to take what they've given you and you're going to ask yourself, Malachi, you guys need to be listening. You're going to ask yourself, what do I know from that information? Just from this information. Try not to look at what they wrote down next. Ask yourself, what do I know from this information? If angle A and angle B are supplementary, what does that tell me? Okay, so they add to equal 180. So what we could write down next is that angle A plus angle B is equal to 180. Is that what they wrote down? Okay, so number 2, measure of angle A plus measure of angle B is equal to 180 degrees. Liam, when you get a chance, if you'll just pick your homework. So what tells us that they add to be 180? Okay, so when you list your reasons have to either be a definition, a theorem, a postulate, or a property. So what are we going to list as our reason for number 2? Angle addition postulate says part plus part equals whole. These are not even connected to each other. We're not doing part plus part equals whole. So again, Malachi, this is where I was saying it goes back to what did they give you and how did we know that? What up here did they give us? That they're supplementary. What told me that that means that they add to be 180? The definition of what? Supplementary. Every single time you're going to have to say, what do I know? What can I say next? And how do I know it? The how do I know it is what goes here. So it's definition of supplementary. And this is where knowing what your definitions actually say is going to be huge. Okay? Very important. Thanks, Smith. I'll put your homework in the chat once you get it. Thank you. Okay? So now, we have the measure of angle A is 45 degrees. That was given to us, and we have this statement. So what did they write next? 45 degrees plus the measure of angle B is equal to 180. So now again, you're going to ask yourself, what did they do to get from statements 1 and 2 to statement 3? Okay, they replaced angle A with 45 degrees, and we call that substitution. Substitution what? property of equality. Very good. And then what is the final statement that they wrote down? Measure of angle B equals 135 degrees. So again, you're going to ask yourself, what did they do to get from step number 3 to step number 4? Very good. Subtraction property of equality. So on these problems, we're doing a mixture of everything. We're looking at all our algebraic properties, all our geometry definitions, all our postulates, all our theorems, and we're trying to get from one step to the next. We'll start off where they give us the statements, and then we'll eventually just have something that they give us and something they want us to prove, and we have to figure out what all those statements will be. So we're just going to baby step through this, and we'll go through several examples today. Okay, so here's another one. They give us all the statements. Again, I'm going to tell you to make this a 2-column proof. Left side should be statements. Right side should be reasons. You're going to read at the very beginning and pick out what are they giving us in that paragraph. So we're given what? Okay, so they gave us how many pieces of information? 2. B is the midpoint of AC and AB is congruent to EF. So number 1, B is the midpoint of AC. Where does that come from? Given. B is the midpoint of AC. So number 1 should be given. But again, I'm going to ask you, did they write all the given down in number 1? No, we have a second part that they haven't used yet. So when we get there, we need to remember that that's our given. Or you can go ahead and find it in your proof and write given. Which statement is our other part of our given? Number 3, AB is congruent to EF. So reason number 3 should be what? Given. And again, the reason that they're not going to put it all at the beginning every time is because they don't need it at the beginning. When they're ready to use it, that's when they're going to write it in their proof so that it's flowing logically. Okay, so they tell me B is the midpoint of AC. That is all I know right now. You can't use things that are below, only what's up here. B is the midpoint of AC. Using only that information, how do I know that AB is congruent to BC? Definition of midpoint. If B is the midpoint, the definition says that it splits it into 2 congruent parts. This part is now congruent to this part. Mark your picture. The very first part of a proof is to take your given and mark your picture. If you can, mark your picture. So now that we know AB is congruent to BC, I'm going to mark my picture. I'm going to mark those little tick marks, and I'm going to put definition of midpoint. Okay? Next, they said AB was congruent to EF, and we know that came from the given. So now we have to look at these 3 statements and ask ourselves, how are they going to get from these 3 statements to statement number 4? AB is congruent to BC, AB is congruent to EF. Now they're saying BC is congruent to EF. Very good. So again, notice this side is AB, this side is AB. Those are identical. If we say BC is congruent to AB and AB is congruent to EF, that's like our middleman that we can get rid of. And then we can combine those 2 parts to get BC's congruent to EF. Now I'm marking in my proof, but never do that when you're actually doing your proof because you want to be able to read your whole proof, okay? And I love that you said transitive property of what? Congruence, because you're looking at what symbol is being used. Is this making sense? Okay, again, if you don't know what the transitive property says, you're going to struggle. If you don't know what the definition of midpoint says, you're going to struggle. So really the best thing you can do to prepare for proofs is to study your properties and your theorems and your postulates and your definitions. Then it makes everything just so much easier. Okay. Again, we've already used the word theorem, but here is the actual definition. A theorem is a statement that you can prove true. Postulates are not proven true. What are postulates? They're accepted as true. There's no way to prove them false, but they have not been proven true. There's no formal proof for postulates, but we accept them as true. I feel like most of the postulates we learn are pretty common sense. Part plus part should equal the whole. That's a postulate. That is our angle addition or segment addition postulate. But theorems sometimes are things that we wouldn't necessarily know unless we have a formal proof for. So they're statements that we have proven true. Okay, so we're going to learn more theorems as we go through these sections. We actually have talked about this, but we haven't given it its formal name. It's called the linear pair theorem. This one is very important. You will use it a lot. Just like vertical angle theorem that I mentioned this morning. That one's very important. You're going to use it a lot. Segment addition postulate, angle addition postulates that we talked about last class. Very important. Going to use them a lot. Okay, linear pair theorem. Linear pair theorem says if two angles form a linear pair, then they are supplementary. We're back to those if-then statements. This is why we had to learn that so that we can understand what we know here. What I love about this chart is it helps us understand this must be a statement in our proof. If we are given, or if we know that A and B form a linear pair, then what we can conclude would be that A and B are supplementary. So if this is one of our statements, this could be a second statement. If A and B form a linear pair, think about A and B. If this is angle A, so I'm just going to put an A here even though really these should be different letters, and this is a B. If together they form a linear pair, then they should be supplementary because they're forming a straight line. Agreed? Okay. So this would be statement number one in your proof, or a statement. This would be another statement in your proof, and this would be the reason that you would list for your second statement, linear pair theorem. Okay, so if somewhere in your proof you have that these two angles form a linear pair, bless you, then you can say that they are supplementary. All right. The next one we're going to talk about is the congruent supplements theorem. This one's new. We have never talked about this before. Congruent supplements theorem. I need you to focus on this because this one's kind of confusing. It says if two angles are supplementary to the same angle, and I'm going to draw pictures to kind of help you understand. If two angles are supplementary to the same angle, so let's say I have an angle here, angle A, and it's 30 degrees. I have an angle here, angle B, and it's 30 degrees. And then I have an angle here, angle C, and it's 150 degrees. Would you agree that A and C are supplementary? Okay. Would you agree that B and C are supplementary? So we have two angles that are supplementary to the same angle. Agreed? A and B are supplementary to C. Each one is supplementary to angle C. Agreed. Okay, so if two angles are supplementary to the same angle, or maybe they're supplementary to congruent angles. So maybe it's a picture like this. So I'm going to call this angle 1 and this angle 2. This is angle 3 and this is angle 4. Which angles in that picture are congruent? 1 and 3. But we notice that 1 and 2 are supplementary, right? And we notice that 3 and 4 are supplementary. So would you agree that angles 2 and 4 are both supplementary to congruent angles? Okay, so congruent supplements theorem says if you have two angles that are supplementary to the same angle, or if you have two angles that are supplementary to congruent angles, then those two angles must be congruent. Would you agree that A and B have to be congruent if they're both supplementary to C? And that angles 1 and 3 would, or excuse me, angles 2 and 4 would have to be congruent if they're supplementary to congruent angles 1 and 3. Okay, so that's the congruent supplements theorem. Now, how this is going to look in a proof is not a bunch of pictures. In your proof, you may have this listed as statements in your proof. Somewhere you may have that 1 and 2 are supplementary and 2 and 3 are supplementary. Notice that 1 and 3 are supplementary to which angle? Look again, you. 1 and 3 are supplementary to which angle? Angle 2, right? They're both supplementary to the same angle. This says if two angles are supplementary to the same angle, what should be true about the two angles? They should be congruent. So what you'll be able to conclude is that 1 and 3 must be congruent because they are supplementary to the same angle. And this would be your reason that you would give for that statement. Congruent supplements theorem. Congruent supplements theorem. You've got to memorize the name. And then you have to know what it says. Some of your homework problems are not going to be proofs. They may be pictures like this, and they may ask you to find some measurements. For example, they may say this is 20 degrees. What's the measure of angle 2? What's the measure of angle 2 going to be? 160. What's the measure of angle 4 going to be? 160. So it may be something like that where you're using the congruent supplements theorem because the only way you can find 4 is by knowing that 3 is also 20, and therefore 4 has to be the same as 2, 160. But some of them are going to be proofs. Okay, and we've already talked about a 2-column proof. I made you set them all up that way. In a 2-column proof, though, you do list the steps of the proof on the left, and you write the matching reasons on the right. And remember that your proof should have numbered, I'll write it differently, numbered statements and reasons. Numbered statements and reasons. So we're numbering everything we write down. Okay, so here's another one. They give us this proof. Now notice this one is not fill in the blank only on the reasons. It's got blanks everywhere, right? So again, when you get to the homework, are you only going to write down A, B, C, and D on your paper? No, you are going to recopy this entire proof. But it will help me out if you will circle your answers in that proof a little bit. Okay? I won't count off if you don't, but it will help me if you will when I'm grading. So you are just filling in the blanks. You are not writing your own proof. You have to list exactly what they did and figure out what goes in the blanks. This is how most of your proofs are going to be. They're going to give you some information and they're going to tell you to prove something. Okay? And pretty soon there will be no box like this. It'll just be given this, prove this, and you've got to figure out how to do it. Okay, so we're baby stepping 2 there. Be very careful, read your directions. This says fill in the blanks to complete a 2-column proof of one case of the congruent supplements theorem. What that means is we are writing a proof that proves the congruent supplements theorem. That means we can't use the congruent supplements theorem. We're trying to prove it. So we are going to prove this theorem down here. And one more time, let's remember what congruent supplements theorem says. If two angles are supplementary to the same angle, then those two angles have to be what? Congruent. Okay, that's congruent supplements theorem. The more we say it, think it, the more it helps stick in our minds. That's what we want to prove. We want to prove if two angles are supplementary to the same angle that they are congruent. So we can't use that theorem in our proof. Okay, here's what we're given. 1 and 2 are supplementary and 2 and 3 are supplementary. The first blank in our statement is blank and the reason is given. So what do you think goes in number 1? Okay, angle 1 and 2 are supplementary. Is given written anywhere else? No, but there is another blank, right? Is that blank next to the rest of the given? No, so that means we're going to list how much of our given in statement number 1? All of it. Okay, so we're going to list all of our given right here. Angle 1 and angle 2 are supplementary. And angle 2 and angle 3 are supplementary. And that's given. Okay? Then I want you to think. Don't just try to fill in the blanks. You need to think through and make sure you understand what they're doing, because you're going to have to eventually do this on your own. So does it make sense that they went straight to statement number 2, which says that 1 plus 2 has to equal 180 and 2 plus 3 has to equal 180? Because they used the definition of what? Supplementary angles. And this is just the way that the book writes angles. It's an angle with a little s in it. You are not allowed to abbreviate. So when you are writing out your proofs, you're going to write out the whole word. Don't abbreviate like they did. Okay? Okay, what are they telling us to use in statement number 3? And again, it's kind of hard when they abbreviate, but it is substitution. I'm going to tell you that that's a typo and that's wrong. I want you to change that. And I'm going to put that what we're really using is transitive property of equality. Transitive property of equality is what we really are using here. If I use the transitive property, what should my next statement be? Nope. Transitive, remember, let's think back to what transitive says. Transitive says if A equals B and B equals C, then the part that is identical goes away, and we say that A equals C. Nope. Look, okay, stop for a second. Look at what you have up here. What part is exactly the same on both sides of the equal sign? Nope, that's a piece. That's one little piece. The entire side of the equation has to be the same as the entire side of the equation. 180. So this is your B that is identical. That's going to cancel out. So what are we going to write when we combine A and C? Okay, so the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. Transitive. One whole side has to be identical to use transitive property. Okay, so then the statement number 4 and reason number 4. The book is going to write reflexive property. Mason, you okay? Okay, you need to keep your head up and take notes, please. The book is going to use reflexive property anytime that they end up adding or subtracting something to both sides of the equation to show you, especially when they're using names of angles or names of line segments. They're going to use reflexive property to just make sure you understand that this angle 2 on the left is the same as this angle 2 on the right, that they're not different angles. I don't understand why we do that, because if they're different angles, we name them different. So to me, it's kind of silly to do measure of angle 2 equals measure of angle 2 by reflexive property. So I'm going to tell you that you don't have to do statement number 4 when you're writing your own proof. Okay, if it's a fill in the blank, you've got to fill in the blanks with whatever they give you. But if you're doing your own proof, that step is not necessary. You do not have to do that. So let's ask ourselves, how are they getting from statement number 3 to statement number 5? Okay, so Remy says subtraction property of equality. What are they subtracting? Measure of angle 2. They're subtracting angle 2 from both sides. And because they're going to do that in step 5, they just want to make sure you realize that 2 is the same as 2 and that they will go away. But you, again, you don't have to have that number 4. Number 5 should be subtraction property of equality. Okay, this last step is very important. You will use it all the time. They tell you to use what? What is this saying? The definition of congruent angles. What does it mean for two angles to be congruent? Okay, they have the same measure. They have equal measures. So if 1 and 3 are equal, the definition of congruent would say if they're equal to each other, then they are congruent. And what is important that you understand is that definitions are biconditional. They go both directions. So if they had told me that 1 was congruent to 3, the definition of congruent would say, if they're congruent, then they are equal. If they tell me they're equal, then I can also say that they are congruent. It goes both directions, and it's the same reason. Every definition is biconditional, and that's why we had to learn that. So what are we writing here for statement 6? Ooh, careful. Angle 1 is congruent to angle 3. No measures when you're using congruent symbols. Some free give me points on every proof should be statements and reasons, numbered. You should have your given listed because that's going to be given to you. And what should your very last statement always be? How am I going to know what the very last statement is always going to be? Okay, the word prove is not what I'm looking for, but what they tell me to prove, 1 congruent to 3, that should be your very last statement every time. Now I'm going to say this again because I've had students write prove as the reason. Prove is not a reason. Reasons are definitions, theorems, postulates, or properties. But your very last statement should be whatever they're telling you to prove. You're done when you get to what they want you to prove. Are we clear there? Okay, let's try some more. Before we get to the next one, we have a couple more theorems that we have to know. The first one should be pretty simple. It's going to save us time though. It is, we'll use it a lot. If you don't use it, you're going to have several steps in your proof. So I would suggest you learn this theorem. It's called the right angle congruence theorem. Right angle congruence theorem, and it says all right angles are congruent. So here's how you'll use that. If your statement here says angle A and B are right angles, if you have that somewhere in your proof, angle A and B are right angles, then you can conclude that that means A and B are congruent. So this would be another statement in your proof. And the reason you can go straight from them being right angles to them being congruent is because of this theorem. Now I'm going to show you what it would look like if you didn't have this theorem. So here's an alternative method. If you have angle A and angle B are right angles, and you don't know this theorem, what does this tell me if they're right angles? Okay? The only way I know they're congruent is by this theorem. So I'm not using that theorem. What does this tell me? What's the only thing I know if I don't use this theorem? Angle A and B are right angles. That they measure 90 degrees. So I could say measure of angle A is equal to 90 and measure of angle B is equal to 90. What tells me that? Say it again. Okay, so what do I write if I were writing a proof here? What's my reason for this statement? Definition of right angles. Okay, now where could I go from here to try to eventually show that these are congruent? Okay, set them equal to each other. So what would I write as statement number 3? Measure angle B. What did you just use to get that? Again, we're not using this theorem. We're trying to prove this theorem. If I didn't have this theorem, how could I go from these two angles being right angles to them being congruent? Say it again. Complementary says two angles add to equal 90, not that each one of them is 90. Reflexive property says something is equal. Jordan, you're going to need to stand up at the back if you're sleeping every day. Okay, it's not good for you, bud. Malachi, definition of, tell me what you said again. Reflexive property. Reflexive property says something is equal to itself. So it would be something like A equals A, or B equals B, or C equals C. Transitive property. Very good, Molly. Notice they're both equal to 90. So we get rid of the 90 and we say A equals B. So this would have been transitive. Okay, and now how can I say that if they're equal, that means they're congruent? Andrew? Exactly. Remember, definition of congruence goes both directions. So if they're equal, now I can say angle A is congruent to angle B. And this would be the definition of congruence. So what I was trying to show you here is if you don't know that theorem, in a proof, you're going to have to go through all 4 of these steps. Or, if you know this theorem, you can just say A and B are right angles, therefore they're congruent, right angle congruence theorem. And it's just one extra step after you know that they are right angles. Does that make sense? Okay, so that would be the long way, that would be the shortcut. Okay, the next one is the congruent complements theorem. This is very similar to the congruent supplements theorem. They say the same thing, except this one's talking about complementary versus supplementary. So congruent complements theorem, again, I'm going to give you some pictures to help make sense. So if I have 2 angles here, here's angle A, let's say it's 30 degrees. Here's angle B, 30 degrees. Here's an angle over here, C, and it's 60 degrees. Would you agree that A and C are complementary? Would you agree that B and C are complementary? Okay, so would you agree that we have 2 angles that are both complementary to the same angle C? Okay, so if 2 angles are complementary to the same angle, or, I'm going to show you another picture. Let's call this angle 1, angle 2. 3 and 4. Would you agree that angles 1 and 3 are both complementary to angles 2 and 4? So we have right angles here. So 1 and 2 are complementary, 3 and 4 are complementary. Agreed? Okay, would you agree that angles 2 and 4 are complementary to congruent angles? Okay, so, or 2 congruent angles. So it could be that they're not congruent, it could be that they are congruent in the picture. Then, if 2 angles, 2 and 4, are complementary to 2 congruent angles, then 2 and 4 have to be congruent. So if 2 angles are complementary to the same angle or 2 congruent angles, then they have to be congruent. And again, how that will look in a proof. If 1 and 2 are complementary, 2 and 3 are complementary. Which 2 angles are complementary to the same angle? 1 and 3. They're both complementary to 2. So what does that mean about 1 and 3? They're congruent. So if this were a statement in your proof, then this could be another statement in your proof, and this would be your reason. Congruent complements theorem, congruent supplements theorem. It just depends if they're saying complementary or supplementary, but they say the same thing. Okay, very important. As these get harder, if a diagram for a proof is not provided, draw your own. The first step to a proof is to mark the given information on your diagram. To do a proof all by yourself, mark the given. You do not mark what you're trying to prove. So you can mark with tick marks or arc marks what you're given, but you cannot mark what you're trying to prove. Very important for your homework. Okay, in your book, they are going to sometimes give you this plan. You need to ignore that plan because you will never get a plan on your test. This is basically helping you figure out what to do. If you get stuck and you have no idea where to go, you can look at the plan. But you need to try not to look at the plan because you will not get that for your test. Okay? So this is our first proof where we're going to try to do it all by ourselves. Given this information, prove this. I'm going to come over here to the whiteboard where I have more room. This will be filled in on the filled in notes if you're watching the video. Okay, so make a T-table. Did I give you one in the notes? Over to the right, does everybody see that there's a T-chart? Okay, so I've set it up for you. That does not mean that you're going to have 5 statements. You might. I just cut and pasted a T-chart for you to save time. So you might have 5, you might have less, you might have more. Statements. Reasons, this is already set up for you. Okay, so number one, what's the first thing that we want to write in our proof? The given, okay? So we are given that angle 1 and angle 2 are supplementary. And our reason is given. Now, I'm going to tell you my best advice is to write down one piece of given at a time and ask yourself, what do you know from that given? And then go back and write down the rest of the given. So I'm going to stop right there. What do I know based on just this statement? They add up to equal 180. So I can write measure of angle 1 plus measure of angle 2 is equal to 180. What is my reason for doing that? Definition of supplementary. Don't make this harder than it is. It always surprises me how they'll give me some information, like they'll say M is the midpoint or AB bisects, and then I'll have students right over here, definition of congruence. They gave you the word midpoint or they gave you the word bisect. It's not the definition of congruence, it's the definition of midpoint or bisect. So use what they've given you. Don't make it harder than it is, okay? All right, this is all we have now. There's really nowhere we can go with just this statement. So now we're ready to go back and pull in the rest of our given. So what else did they give us? Angle 1 is congruent to angle 3, and our reason is given. Would it be wrong if I put all of that in one statement at the beginning? No, but I just think it's easier to look at each one and say, what do I know from this information? Okay, what do I know if 1's congruent to 3? They equal each other. So number 4, I can say the measure of angle 1 is equal to the measure of angle 3. How do I know that? Good, because they said they were congruent, and congruent means, so definition of congruence. Now, it may not be necessary to write that down, and I do not want you to write everything you think, only if it's necessary to get to your goal. So I'm going to stop for a second and let's see if we really needed to put this here. So let's go back and look at what we're trying to prove. Our goal is to prove that 3 and 2 are supplementary. What does it mean for 3 and 2 to be supplementary? They have to add to equal 180. And right now we have 1 and 2 equal 180. We want 2 and 3 to equal 180. And we know that 1 and 3 are congruent, right? So any ideas what we could do to get that 2 and 3 are going to add to be 180? Transitive says you have the same exact thing on one side, same exact thing on one side. Say it again. Set what equal to each other? Angle 2 and angle 3. Like set this equal to this. Like what are you saying what I would write? Okay. Reflexive says something is equal to itself. Who said substitute? Okay, what would I do, Malachi? What am I substituting? Okay, so notice that we said 1 and 3 are congruent, and our goal is to show, sorry, I guess I touched that. Our goal is to show that 3 and 2 are supplementary, and you said that that means 3 and 2 would add to be what? 180. And so Malachi says, well, if angle 1's the same as angle 3, can't we just put 3 in for 1? Would you agree with that? Okay, here's the problem. You cannot plug something that's congruent into something that's equal. So we would have to do step number 4 then before we can use substitution. We do not have a substitution property of congruence. We only have a substitution property of equality. So you would have to change it to equals first, and now we can use substitution. Very good. So number 5, I'm going to go ahead and write the reason, would be substitution property of equality. And again, we're substituting angle 3 in for angle 1. So what is our statement number 5 going to be? Measure of angle 3 plus measure of angle 2 equals 180. Does everybody agree with that? Okay. Now, is that what they told us to prove? No, it's close, but it is not word for word what they told us to prove. And our answer has to be word for word what they tell us to prove. So if 3 plus 2 is equal to 180, what do I know? That they're supplementary. So I can say angle 3 and angle 2 are supplementary. What tells me that if they add to be 180, that means they're supplementary? Definition of supplementary. Again, it goes both ways. It's biconditional. If they're supplementary, then they add to be 180. If they add to be 180, then they're supplementary. So it's still the definition of supplementary. Questions? Any questions? All right, if you look at the next one, is this the last one in your notes? Okay, I want you guys to try it on your own, and I want you to ignore, hold on, let me point out two things before you jump in. One, ignore this plan. Oh, that's not it? Oh, you don't have a, good, I took it off of yours, because I don't want you to use it, so ignore this one up here. Don't look at it. It's only going to hurt you because it's going to make you think you know what you're doing when you don't. Hopefully you'll know what you're doing and you don't need it. All right, and read the directions because this gets people every time. Use the given plan. Don't use the given plan. Write a two-column proof of one case of the congruent complements theorem. So if we're proving the congruent complements theorem, can we use the congruent complements theorem in our proof? No. So you cannot use that theorem. Are we all clear? You can use anything else we've learned. Given this, prove this. Okay, take a few minutes, you and your partner, talk it out. If you need to turn around, work with someone behind you or in front of you, feel free. And I'm not going to help you right now. Talk it out with your partners. I'm going to give you a few minutes, and then we'll check it, and we'll talk about it then. Always. If you're watching the video, I forgot to hit start again, so look at the filled in notes and you will see all of the proof worked out. The only exception is you do not need statement number 4 in your proof. 7